Alright, and where we left off, we were talking about, in the last video, our galaxy. And it's the Milky Way galaxy, and it was about 100,000 light years from one side to the other, and about 2,000 light years thick. And it had roughly over 200 billion stars in it. But now we're going to go ahead and wipe it clean, and we're going to talk about distance between galaxies. Let me grab this. And our galaxy, so I want to do a better job of drawing it. Alright, whatever. Okay, this would be the Milky Way. This is the Milky Way. Alright? And it's roughly 100,000 light years from end to end. Alright, and then there's some other smaller little galaxies kind of by us, but the closest spiral galaxy, which is actually a significant spiral galaxy, is actually Andromeda, and it's bigger than us. It actually has about 1 trillion stars. And now this is bad. It actually has about 1 trillion stars. It's a huge spiral galaxy. And one thing about Andromeda, I hope I'm not, sorry. Anyway, one thing about Andromeda is that it's actually a galaxy that's close enough, believe it or not, that we're gravitationally pulling towards each other, and one day in the very, very distant future, we'll actually collide into each other. But anyway, because we're moving towards each other. All the stars in this galaxy and all the stars in our galaxy, they're blue shifting. So we can tell. I'll talk about that in later videos if I continue to make these, which I hope to. But all these stars are moving towards us because we're gravitationally pulling each other in. But anyway, the distance between Milky Way and Andromeda is an insane distance. It's 2.5. Is that? Yeah. Sorry. It's 2.5 million. Let me write that out. It's 2 million 500,000 light years. It's 2.5 million light years from the Milky Way to Andromeda. So that gives you an idea of the distance that gravity reaches. Gravity is a really weak interaction. I mean, we think of gravity and we think, oh, it's pretty strong, but really it's not, because if you think about the fact that when I pick this marker up, I'm actually outdoing the gravity of the entire Earth. I mean, you know what I'm saying? It's a really weak interaction. It gives us life as we know it, but it goes forever. It goes for long distances. I mean, it takes light 2.5 million years to reach this distance, and we're close enough that this galaxy is actually coming towards us. But anyway, one thing about it when it does is that really, you know, you think about this entire huge galaxy and this one colliding and how crazy it would be, but we have to remember the Sun and Alpha Centauri. There's 4.2 light years between them. When these things actually collide, almost all of this is empty space, and almost all of this is empty space. So they could almost just go right through each other. And really, it'll take so long. I mean, this won't be a collision like, I mean, this would take, as they approached, and let's say they got to where the first stars could touch. From them to go from this distance to this distance would take 100 million years. You know what I'm saying? I mean, that's how long it will take. And really, most of the stars will just pass through each other. And then they'll kind of, they've played it out on a computer simulation if you want to see it, and it's pretty cool. You can probably get online and just look at it. But they'll swirl around, and I think it's probably like a couple 100 million years. It'll actually turn into one, you know, and they'll probably supernova and everything else, a bunch of supernovas, I'm sure, and all that. But anyway, let's get back to our story. 2.5 million light years to the very closest actual significant spiral galaxy. And now we're going to go ahead and wipe this clean and move out to the next big thing, which is actually, it's crazy how things kind of gather up, and not just stars gather up into galaxies, galaxies gather up into clusters. And we are actually part, and if you look, each one of these dots would be considered a galaxy, alright? And there's millions, billions even, billions of galaxies. And this right here would be really our Virgo supercluster. It's a cluster of galaxies. Galaxies actually cluster together the same way that stars cluster together and make galaxies. Galaxies cluster together and make clusters of galaxies. And we're actually part of the Virgo supercluster, and it's roughly about 100. It's roughly about 150. I hope that's right. Million. You see that? Sorry, I keep doing that. 150 million light years across, and there's millions of galaxies in this. So I mean, each one of those specks is billions of stars, or even trillions of stars. You know what I'm saying? All right. So now, if we take all this, think about this square right here, and we're going to go ahead and wipe it on down. We're going to wipe it down, and we're going to put that square about this big right here, and we're going to go on out to all these super clusters near us, because there's tons. We're about right here, because we're going to say we're there, we're Virgo, and you know, there's Capricorn, and there's Hercules, and there's a lot of super clusters. So each one of these little black squirrels is actually millions of galaxies. So right here there's actually billions of galaxies, and this right here, these super clusters near us, and these are just the ones near us, would be equivalent to about 1 billion light years across. Which is, so a photon emitted right here would take it 1 billion years to go to right here. And now I'm just going to go ahead and wrap this up. We're going to take this square and we're going to put it into perspective with the entire visible universe. We're going to put that square right here, alright? And then we're going to go out and we're just going to draw a circle, because that's how we kind of see our visible universe, because all we can see is the light that's had time to reach us. All light out past this area could never reach us because it's out too far. It hasn't gotten to us yet. But this right here, and I mean, the crazy thing about it is when you look at the visible universe from this distance, it's almost just like a uniform. It's almost just uniform mass. I mean, it's almost just uniform, and really, each one of these little squiggly lines would just be billions of galaxies, and there's actually billions and billions of galaxies in our visible universe. But this distance from there, from where we're at to right here in this entire circle, is roughly about 13 to 14 billion light years. 13. I don't even have room. I don't even know if you can see it. 13. You know what? Let's just do this. 13 times 10 to the 9th. I think I did that as a P. Times 10 to the 9th. How's that? I suck. Anyway, 13 times 10 to the 9 light years. And that is our visible universe. So, remember where we started? We started with the Earth. Remember? And the Earth was a massive object that became a speck into a speck into a speck into a speck into a speck, and then we got all the way into clusters and superclusters and superclusters near us, and then all the way to this visible universe. And it's about 13 billion light years across. And if that doesn't freak you out, then I don't know what will.